Imagine vanishing completely. No people, no Earth, no stars. Imagine deleting every single atom from the universe. What is left? Common sense says nothing. But physics says something terrifying. What's left is a vibrating, ravenous monster that is practically boiling with life. You see, a true vacuum isn't an empty stage waiting for actors to show up. It is the actor. Space-time is a physical fabric. It can stretch, ripple, and literally twist. If we look at the smallest possible scales, we find constant quantum fluctuations. This nothing is actually giving birth to matter and antimatter, which immediately devour each other in tiny bursts of self-destruction. Today, we're tearing apart the universe to see what's actually holding it together. It turns out nothing is the most dangerous thing in existence. Let's go. Let's start with a very human desire, wanting some peace and quiet. If you wanted to get as far away from another human being as physically possible, your GPS would point you right here. Point Nemo, the oceanic pole of inaccessibility. The nearest inhabited land? Over 2,500 kilometers away. But here is a fun fact. Your closest neighbors at Point Nemo are actually the astronauts aboard the International Space Station. When they pass overhead, they are just 400 kilometers away. Too bad they don't offer room service. But even a desolate ocean is way too crowded. It's full of water, microbes, and bad Wi-Fi. To find real emptiness, we have to leave the planet. We have to go to the great nothing. Behold, the Boötes void, an enormous cosmic desert. A normal patch of space this size should contain thousands of galaxies. In Boötes, we found only 60. It's so empty that if our galaxy were in the middle of it, we wouldn't have discovered other galaxies until the 1960s. And plot twist, we are also cosmic hermits. Our Milky Way sits right inside the KBC void, which is 6 times larger than Boötes. We are literally born in the cosmic suburbs. Okay. Space is big, and we're lonely. We get it. But it's about to get much weirder than just empty space. Let's say you travel even deeper into the void. Outside of any galaxy. No stars, complete and utter darkness. No point of reference, no sense of speed. Is this absolute nothingness? But actually, no. Even in this endless dark, every cubic meter of space still contains a few stray hydrogen atoms. Extremely lonely, but definitely there. Fine, let's cheat. Let's manually vacuum those last few atoms out of the room. Welcome to the classic vacuum. This is where sound dies, because there is no air or water to carry its vibrations. The audio is gone, but the medium itself remains active, because even in absolute silence, we can detect gravitational waves. Over 1 billion years ago, 2 massive black holes collided. They didn't shake the air, they shook space itself. They generated waves of stretching and squeezing space-time that traveled across the universe and passed right through you in 2015, warping your body by a fraction of a proton. Think about that. If gravitational waves can travel through a vacuum, it means the vacuum isn't nothing. It's an elastic sheet. It's the same with light. When light passes by a massive star, it bends. But photons have absolutely zero mass. Gravity shouldn't be able to pull on them. So why do they bend? Because the light is travelling in a straight line. It's the vacuum itself that is bent. Space isn't just a stage. Space is a giant invisible trampoline, and gravity is just the heavy guy standing in the middle of it. But to see why space acts like a trampoline, we have to look closer. Not just microscope closer. We need to zoom into the very pixels of reality. 19th century physicist James Clerk Maxwell said a vacuum is what's left in a jar when you remove everything you possibly can. But let's zoom past the atoms and dive into the Planck scale. You see, at that scale, we hit the 0-point energy limit. The universe is literally too jittery to ever sit still. Even at the coldest, emptiest point, everything is still shaking with energy. It's like trying to stop a pendulum with your hands. You can get it incredibly still, but at the quantum level, the microscopic tremors in your own hands will keep it vibrating forever. The vacuum has a minimum temperature, a restless energy that never sleeps. Out of this restless energy, virtual particles are constantly popping into existence, out of nowhere. They meet their antimatter twins, annihilate, and vanish back into the void. Space is a boiling quantum soup. And if you have a boiling soup of infinite possibilities and an infinite amount of time, eventually the vacuum is going to spit out something incredibly weird, like a fully functioning, conscious human brain. Statistically speaking, a hypothetical construct known as a Boltzmann brain requires approximately 10 to the power of 10 to the 50 years to spontaneously assemble from these quantum fluctuations. This brain would materialize in the empty, dark, freezing cold of space. It would appear alongside its corresponding antimatter counterpart, exist just long enough to have one single brief thought, like, wait, why am I here? And then instantly explode as it annihilates with its twin. Talk about an existential crisis. But if the vacuum can accidentally make a brain, why did it make a whole universe instead? The answer is the biggest mistake in history, and it's the only reason you're watching this. But if the universe is so good at creating things in balanced pairs, why are we here? Why do we have stable planets, stars, and coffee cups instead of just an empty void of light? This is the biggest manufacturing defect in the history of reality. In the first split seconds of the Big Bang, equal amounts of matter and antimatter should have been created. The net result should have been total annihilation, a sterile universe of pure, empty radiation. But it wasn't! For some mysterious reason that still keeps physicists up at night, there was a tiny asymmetrical glitch. For every 1 billion antimatter particles, the universe created 1 billion and 1 normal matter particles. That tiny 1 in a billion excess is us. Every star, every galaxy, every drop of water, and your left pinky toe. We are just the crumbs left over from the greatest cosmic bar fight in history. So, what is nothing? It turns out nothingness is just a concept we made up to appreciate when something is there. You can't find true nothingness in this universe because you are here to look for it. We are the universe's way of thinking, feeling, and wondering. If you want to keep exploring the weird underbelly of space-time with us, hit that subscribe button. Until next time, stay silly.